Let's move on to the independent samples t-statistic, and let's take a look at our output that we got when we analyzed the data. We got a couple of different boxes for our t-test. The top box is a set of descriptives. We can see that we had 26 women and 17 men take part in this survey. And their mean for addiction to social media their means are actually pretty close. So women were at 2.29-ish and men were at 2.11. Here are the standard deviations for each group and then the standard error means for each group. As you can recall from your independent sample statistic, the SPSS program is using these numbers to create that pooled variance, which goes into determining how much error you might expect when you're looking at the mean differences of these groups. So just like before, we have some extra information that we don't need. This Levene's test for equality of variances, for those of you who are interested in what this is, it's making sure that the variances of the two groups aren't wildly different from each other. If they are, then we can't actually perform a t-test. In this class, our variances will always be what we need them to be in order to run these analyses. If they weren't, then we would use this bottom row. So because we don't have to worry about that, we can just ignore this bottom row altogether. Just pretend as if it's not even there, which is basically what I do at this point in time. So you don't have to worry about Levene's test. That's always going to be what we need it to be, and that means that we can avoid this bottom row. We are also given this 95% confidence interval, which we saw in the last analysis, and we are also going to ignore that because that's sort of like effect size, and we're going to report effect size using R squared. But the rest does end up being important. So the most important things that we need are the t and the degrees of freedom. As you saw with the single sample t, we will need both of these numbers in order to write up our results. And we also have the exact p-value, once again, under the sig. That's your exact p-value. So we want that p-value to be less than 0.05, and that means we can reject the null. So just like in our single sample t-statistic test, when we go to step 2, we're not looking for a critical region, we're only looking for a p-value less than 0.05. So basically this number tells us whether or not our t that we calculated for our sample is in fact in the critical region. That's why we use this as a shorthand to tell other researchers what our p-value was. So let's put this in the framework of the hypothesis testing that we've been learning in this class. Our null hypothesis is that men and women are equally addicted to social media. In other words, there's no difference between them. You can also put that as the difference between the two the means for the populations they represent is 0. Our alternative hypothesis is that men and women are not equally addicted to social media. In other words, the difference between them does not equal 0. In this case, once again, I'm doing a two-tailed test because I'm not sure whether men or women would end up being higher. And in fact, for this study, the difference between men and women was not a main hypothesis for the researcher. We're just doing this as practice. Again, the criteria is that we have a p-value of less than 0.05. If we get that, then we will reject the null and we will have found support for the hypothesis that men and women are not equally addicted to social media. This is the probability that the mean difference really is due to error or chance, right? And so we want, if there is a difference between them, usually we're hoping that it's not due to error or chance, that it has something to do with real true gender differences. So we don't need a critical region because SPSS calculates our exact p-value. In our output, we saw a t of 0.705. At this point, you all should know that's not good enough to reject a null. In fact, our p-value is very, very high. It is a 0.485. So we failed to reject the null. Men and women are equally addicted to social media. And I should say that they're both equally casual users of social media, since we saw that our sample is not actually addicted to social media. All right, so let's move from data analysis into writing this up in APA style. So here's our basic template. Once again, you don't have to be exact. What I'm showing you is the kinds of information that need to go in your write-up, but if you try and put it into this template exactly, it can end up grammatically incorrect or just sounding very odd. So you want to make sure that all the information that's in the template is somehow in your sentence, even if it doesn't end up being in the exact way that I have it in the template. So you want to get across that one of the groups was higher or lower in the variable that you measured. So you supply the mean and standard deviation of that group, then the participants in the other group, and you supply their mean and standard deviation. Regardless of whether it's significant, you can say that one group is higher or lower. Then you go on to tell the reader if it is significant, that it is. So the mean difference was significant. Again, we have this T, right? So this is telling the reader which statistic you ran, how many degrees of freedom you had, and then you're going to put the T value that you found into the X's here, your exact P value here, and then if you got a significant result, you supply your effect size, so you would put your R squared there. If it is not significant, so we did not find a significant difference, you have failed to reject your null hypothesis, and the mean difference was not significant. Again, your T with your degrees of freedom and your exact p-value. We do not report an effect size because there's no reason to. If there's no significant effect, then we don't need to inform the reader of how meaningful that effect or difference is. So we're going to add on to the results that we found for our single sample T and add our independent samples T. So we found that women were, and I put slightly higher because the difference was very, very tiny. So women were slightly higher in addiction to social media. I give the mean and standard deviation, again rounded to 2 decimals, than men, same thing. The difference was not significant. Here's my T with my degrees of freedom, and we round to 2 decimals and my exact p-value. You'll notice that my degrees of freedom are actually different for these 2 different tests. The reason for that is that I lost a participant in this analysis because they did not supply their gender, or they did not mark male or female. Perhaps they marked a third gender. So because of that, I've lost one person, so I've lost 1 degree of freedom in my analysis. As you all know, this would change the critical region that you're using to reject the null hypothesis. So we've done 2 tests so far, 2 different types of T statistics. We're going to move on to the ANOVA. Let's take a look at our output, and there is a lot going on when you run a one-way ANOVA, or as we just call it, a regular ANOVA. There's a lot of output to look at, and I'm going to walk you through this step by step. So make sure that you're following along on slides or as you're taking notes, because you will need to read these outputs in our lab. In the SPSS output, you'll see one way, and that's the ANOVA that you ran. So you'll see some things already that I keep telling you to ignore, and that of course is our 95% confidence interval. We don't need to look at that for our purposes, so you can just ignore that part of the table. What you do get are your descriptives, and this is your descriptive box. So here we were looking at amount of self-presentation based on what kind of social media you tend to prefer. In this particular study, Facebook was not an option, so it was only Instagram, Snapchat, or Twitter. So we had most people saying Instagram and then some people saying Snapchat and Twitter. Even though the means for these 3 groups are actually pretty similar in terms of how much they self-represent or self-present within their daily lives. So that measure is really about in general, not just on social media. And then we have the standard deviation, and this is good because we will have to report these. So we need our means and we need our standard deviations for all of our groups that are in the ANOVA. So make sure to highlight those in your output or write them down somewhere so that you can put them in your results. This bottom table here should look very similar. It is a source table. So we have between groups, within groups, how much variance is coming from between and within. Remember, we want our between to be bigger than our within because that means we're getting a treatment effect. In this case, we would be getting an effect of the kind of social media that people prefer. So any differences we find may be due to the types of social media people like to use. Here are sums of squares, just like you calculate on your own. Our degrees of freedom, you'll see our between and within add up to our total. And then our mean square, and then our F. So you know that the F ratio is simply our mean square for between divided by our mean square for within. 0.602 is not great, as you know from class. You want that to be above a 1, and it's not above a 1. So that's no surprise that our significance, our p-value, is not high. So we've added one column to this source table, and that's the p-value for the F ratio. So you'll need your degrees of freedom when you go to report what your F ratio was for your ANOVA. So make sure to note those. In addition, of course, you'll need your F ratio, which is given to you here, and then your exact p-value. As always, we want the p-value to be less than 0.05 in order to reject our null hypothesis. As you can already see, that's not going to happen here. However, we need to continue to look at what happened with Tukey's. And in this case, you know that none of the comparisons are going to be significant because we failed to reject the ANOVA. Oops. Sorry, I got rid of that. But I do want you to see what the post hoc output looks like because it can be confusing. When you run Tukey's, you're going to get output that looks like this. There's a lot going on here, so let me walk you through. Again, we're looking at people's amount of self-presentation based on what kind of social media is preferred. So right off the bat, something should look familiar that you're going to ignore, and that is this 95% confidence interval. So just pretend like that's not there. Now, what this table is doing is it's taking one preferred social media, so for example, Instagram, and it's comparing it to all of the other possibilities. So we have Instagram compared to Snapchat, and then Instagram compared to Twitter, because those are the other two conditions. Then it does the same thing for the next one. So it takes Snapchat, and it compares it to Instagram, and it compares it to Twitter, and then Twitter, and compares that to Instagram, and compares that to Snapchat. What that means, as you'll see, is that you get more comparisons than you actually need. It's doubling up the comparisons that you need to report. So let me show you that in a little bit more detail. So here we have Instagram as compared to Snapchat. So people who prefer Instagram and people who prefer Snapchat, this is how different their means were. They were different by 0.066 points, which is not very much. And because of that, their p-value is very high. They're basically the same mean. But because then SPSS is also comparing Snapchat to Instagram over here, this is still the same comparison. As you'll see, their mean difference, right, is the same. And so is their p-value. So that's, still want that to be less than 0.05. But we're seeing that this comparison here of Instagram and Snapchat, and then Snapchat and Instagram, these are actually the same comparison. So we only need to look at one of them in order to tell us which of the comparisons in the Tukey's is actually something that we would need to report. So you'll see it again here. Here's Instagram compared to Twitter. Their difference is about 0.26 points, not significant, 0.601. Again, we see Twitter compared to Instagram at the bottom. That's the exact same comparison. That's why you get the exact same p-value. And then finally, we have Snapchat compared to Twitter, and we have the same comparison down here. So again, same basic difference between the two means and the same p-value. So when you look at your Tukey's post hoc, you're going to realize that you have twice as many comparisons than you actually need. So if you have 3 groups, you usually make 3 comparisons. It's going to give you 6. So here we have 2, 4, and 6. If you have 4 groups, we usually do 6 comparisons, and so you're going to have 12 comparisons in the Tukey's. You just have to ignore the duplicates and just look at the 6 that you know that you need. Finally, we have this table down here, And I'm going to go ahead and have you ignore that because it's giving you the same information as here, but in a slightly different way. And I've found that students are more confused by it than anything. If you are interested in it, I can explain it more. Basically, the groups that are significantly different from each other, you will see in different columns. Because, let me show you this again, because none of these are different from each other, they're all in the same column. But let's say Snapchat had a really high self-presentation, it would actually be in a second column over here by itself, so that you know that it is significantly different from the other two. Okay, so that's two keys. So let's put this all together again in our hypothesis test. So as always, our null hypothesis for an ANOVA is that all groups have the same amount of self-presentation. In other words, there's no differences. As you all know, we can write this in statistical notation. So mu1 equals mu2 equals mu3 because we have three groups. Our alternative is that there is at least one group that is significantly different in self-presentation. We can't write this as statistical notation. We have to write this out as a sentence. As always, our criteria is that our p-value is less than 0.05. This is the probability that the variance we're picking up is only due to individual differences or error, right? And we want that to be less than 5%. So we want the probability that the variance is due to only individual differences and experimental error to be less than 5%. So we don't need a critical region because SPSS calculates our exact p-value. And that tells us whether our variance that we are looking at in our study, in our sample, is within the critical region that we were hoping for it to be in. But it is not, right? Our F value is 0.602, our P value is 0.553, definitely not below 0.05. It's very big. And so we fail to reject the null. So in this case, it looks like all groups have the same amount of self-presentation. Now, this is fine actually for this particular study because this was not a hypothesis that the researcher had going in. So the actual hypotheses will actually be in the last lab in which we look at correlations. So how do we actually write this up? Again, I'm going to give you a basic template, but you don't have to match it exactly. So you would write that the ANOVA indicates that there is at least one significant difference between groups, and you want to say something about what those groups are. You'll notice that we report the F, because we got an F ratio, and we actually have to say both of our degrees of freedom. Degrees of freedom between, comma, degrees of freedom within. Then we fill in the F ratio we got, the exact p-value we got, and then if it's significant, we would put our eta squared. And that is our effect size, very similar to R squared. For Tukey's, we would write, because it is significant, in particular, group 1 differed significantly in whatever we measured variable from group 2 and group 3. One of the things that I want you to realize is we don't have means or standard deviations here. All we have is p-values. So any significant comparison you need to list. This one just happens to be that group 1 is different from group 2 and 3, but you'll notice that I don't have anything about group 2 versus group 3. You only want to list the things that are significant. So because group 2 and group 3 are not significant for this basic template that I'm giving you, I'm not putting them in there. So you're only going to list the things that are significant. Otherwise, it gets too unwieldy. It gets too much for the person to read. If it is not significant, then you would only be writing that first sentence because you don't need two keys. So you would simply write that the ANOVA indicates there were no differences between groups. Again, saying something about what the groups are. Your DF between and DF within are necessary within your F ratio, and then you report the p-value. We don't need an eta squared because there was no significant effect that you need to further elaborate on. So like I said, we're not putting means and standard deviations here. The reason for that is because when you have an ANOVA, you want to give your participants something easier to read, and that would be a data table. So here we have a template where if you had three groups, You have your group 1, group 2, group 3. You would actually label these with whatever your levels happen to be. Okay, so whatever levels you happen to have in your study, you would label them here. Then you report your means and standard deviations for each group. That way, it's really hard to read means and standard deviations when you have 3 of them. And if you have 4 or 5 of them, if you're running an ANOVA that's even bigger, it's much easier for the person to read if it's in a table format. So you don't have to put it in the text, you can just put it in the table. So here's an example. It's not from our study, but let's say that you ran a study in which you were looking at different kinds of study habits. So in this case, we have 4. So here are our 4 labels. One set of students only read the material once. One set of students read and then reread the material. Another set of students read and then answered some prepared questions that an instructor gave them. And then finally, we had a set of students who created their own questions after having read the material and then answered those questions. So here is how well they did on an exam of the material that they were studying. So as you can see, the students did progressively better. And then here are their standard deviations. So you can't tell from the table which ones are significantly different. You would want to get that from the text, but at least here you can very easily compare the means and you don't have to sort of look through the text to see what those means were. So we're going to use tables when we run an ANOVA. So for our purposes, we would write that our ANOVA was not significant. So the ANOVA indicates that there were no differences in self-presentations based on the type of social media people preferred. So here is my F ratio with my degrees of freedom between and degrees of freedom within. Again, now we've lost people. No, we have everyone because it's big N minus K, so that's good. Everyone who did the addiction to social media was also in this ANOVA. So they had a 0.60, again, only to 2 decimals, and a p-value of 0.55. So if you're following along at home, we actually have stuff that we can add to what we did in the first lab example. So in our first example of SPSS, we were looking at simply the method section and how it is that we describe our participants. So this is the paragraph that we came up with in our first go. Now we might add something to the results section. So there's a lot more stuff that goes into the method section. So stuff about your measures, stuff about any manipulations that you did. But for our class for statistics, we're really focusing on the results section. So for this part, I literally just put all of those 3 sentences together that we came up with. So NSD students were lower in addiction to social media. That difference was significant. Women were slightly higher in addiction, but it was not significant. And then the ANOVA indicates that there was no difference in self-presentation based on the type of social media people preferred. So you can start to see how we're building those results sections that you may be reading in some of your other classes. So now maybe they're making more sense. But as you'll notice, all of this comes after the hypothesis test. The hypothesis test is really what you're doing as you're doing the research. And then when you finally get your data that you've gotten from your participants, then you can run the analysis using SPSS, and then you can go ahead and write up these results. So our hypothesis testing that we're learning in our class is really about what you're doing as you're researching and not necessarily what you're writing up at the end of the day. So hopefully what you're studying and reading in this class and other classes is making more sense because of these labs. All right, so if you have any questions, make sure to ask me, and I look forward to helping you learn more about SPSS and how it can help you in conducting original research or in understanding research that others are doing. Thanks for listening.